webcam?
Yes, we can.
Yes.
Mm-hmm. Okay. And then it's moving. You see my hand?
Yes. Yes.
Okay. Very good. Okay. So I'm going to talk about the NanoPlus, the solid sample feature. This is this is how it looks like here, and I'm going to go through and walk through how to put everything together and how it operates and everything. I just wanted to mention, I think from the previous, I just want to go through this little schematic here real quick. This is something I showed before. I don't know if everyone has seen this or not. This is in the NanoPlus manual. This is the optics arrangement. This laser right here is set for size. This one is set for zeta potential. And for everything except the high concentration zeta cell, the light path comes to this mirror and is forward scattering through the cell to the detector. The high concentration, remember, it for percent solids or anything that looks opaque, the suspension looks opaque, it would be it would be not necessarily 90-degree scattering exactly, but it has to go through the transparent electrode, so it follows this light path. That's the only one that follows this light path. Everything else will follow this forward scattering light path. And so this is the layout of the cell. It applies pressure on the sample to hold it in place. You have the liquid chamber in here. This is where we put the monitoring solution, which is a latex particles that have a known zeta potential. We have the electrodes down here and a circular kind of come in contact with the cell and with the electrodes, and the particles. And we're looking at the interaction of the particles, the probe particles, with the surface to calculate a zeta potential of this solid plate or film or whatever it may be. Here's another illustration. Let me go to this. This is actually what it's actually doing. So you have the electrodes here, positive, negative. You have a cell wall here that's zero charge, which is the bottom quartz of the quartz cell. And then you have the actual sample laid up above here. And these probe molecules are going to interact with the surface of the sample as opposed to the surface of the cell because of the coating. There's a special coating that's placed on the cell, so that way we don't have any kind of interaction that way. So I'm going to put this on speaker, and then I'm going to show you the cell that I have here. Okay, can you still hear me?
Yes.
Okay. Oh. This is the monitoring solution that we use. It comes with the sample cell, and again, it's like some standard particles that are used for the zeta potential measurement for the solid surface. To actually use this, you have to make a dilution. It's very concentrated. So we made a dilution. Here's the dilution that I have, so it's transparent. This is the cell. The quartz. Remember, I mentioned to you this quartz actually is going to fit in here inside this cell. The quartz is submerged in water and chem wipes to keep it moist. Remember, we have that coating, that's very thin coating on there that's protecting the cell so that it stays on zero charge, so it doesn't interact with probe molecules or probe latex. We want the only interaction to occur with sample. I'm going to bring this webcam a little bit closer. That's what I'm doing. So we have this special tool that comes with the cell holder. Just loosen up the top screws. Yeah, this just comes off. This is the lock. This is what applies the pressure to hold the sample in place when it comes down. This comes off. Now the quartz fits in here, but I'm going to continue taking this apart so you can see all the way down to the bottom where the electrodes are. Now this last part, you don't actually have to go down this far.
Mail yapmış diyor. And please confirm that your final defense is really tomorrow at 9 a.m. Tamam mı? Yani real kelimesi öyle yap.
I'm sorry? Hello? Did someone have a question?
No, I think it was Lauren, right? I'm not sure, actually. I thought Lauren was talking.
Oh. All right. Okay, well. All right, well, I'll just continue. I just heard somebody talking. I don't know if it was a question or not. Okay. Yeah, again, I was saying that you don't actually have to go through this on a regular basis to go down this low with to expose the electrodes. Normally, you just have the quartz sitting right in there. But this is just to be thorough for maintenance. So this comes up. These are the electrodes. There's a shiny side and a dull side. The shiny side is goes down, and it fits right in here. You can see how the connector, this connects to the instrument, the positive and negative, and it goes down to this plate, and then you actually place the electrode again with the shiny side down. It's there's a little groove in here, so it fits perfectly in there, so you can't, it won't come out. So you can't really misplace the electrode. That's the other one. And it goes in there. And you see this is where the liquid comes in when we have this entire cell put together, and you have the openings with the O-rings. And the kit comes with extra O-rings to maintain the seal. And there's only one way to put this back together. You can see that there's like a little, I don't know, like a little bump right here. If you try to put this together the wrong way, it's not going to work. You have to put it in exactly the right way so it fits. So again, there's only one way to put everything back together. I'll put this back on. So what I'm going to do now is the quartz sample, or the quartz cell, peel off the parafilm and take it out, rinse it, give it a You can see how this is wrapped in a tissue. This could be a Kim wipe, or it could be a lens paper. Be very careful doing this off. This is the quartz. Rinse it off. Now, because this is going through the cell, the most sensitive parts are the this side, like this side right here, and then this side on the other side. Those edges are the most important parts you want to make sure are spotless and take the most care of. The entire thing on the inside, you want to also be careful not to scratch the surface on the inside, because again, it has that the coating that gives it a negative charge, so it doesn't interact with the probe molecules. So this side has a little opening. This side is actually a flat, solid sheet. So this the opening actually lays up with this. Again, just from touching it. Okay. This. Quartz now is inside the cell. Now we have the quartz in here. I'm going to take this part and place it over the quartz so that it holds it in place and fall out. This is like a kind of like a torque wrench. You can't over tighten these screws. Once there's resistance, it'll stop spinning. Okay, so I have the quartz in here. I have this locked down. I'm going to set this up to run the standard. Just a verified operation of the cell. This standard is PMMA. I don't know if you can see that. Polymethyl methacrylate. It has a zeta potential value of negative 17.9 plus or minus 10 millivolts. I'm going to place this in here over the opening for the cell. So now when the cell is complete, I just have to close everything up and tighten it. Something somewhat of a filler or a spacer. For this. This allows me to put pressure on the sample without damaging the cell. There's a piece of Teflon and a piece of silicone. So since this sample is really rigid, I'm going to use the silicone piece right above it. This on top.
Silicone.
Now the sample is in place. I'll turn the lock to apply pressure. This brings the little holder down, puts pressure on the silicone, puts pressure on the sample so that way I don't have any leaking. Now this is just like a regular zeta potential cell. All I have to do is just add the filling solution, which is this monitoring solution. Again, I'll put 2 because this is set up like a flow cell. We can use the auto titrator for this as well and do some pH studies.
Which solution are you putting in?
I'm sorry?
Which solution you are going to put?
This solution is it's a dilution of this, which is standard particles. Because I need to use particles that I have that have a known zeta potential to monitor this. So you can think of the solution or these particles as as part of the sample apparatus, the cell apparatus, and your sample is the film. Zero charge solution. So these are just monitoring particles. Again, this part here is just a dilution of this. Okay. So now, here. now I just, again, push back and forth, and you'll see like the liquid, flowing through the cell.
Okay.
And we'll just make sure that there's no bubbles. Sometimes when you do the solid surface, you just have to make sure that the entire surface of the sample is wet and there's no bubbles coming through. So looks good. I'm going to remove these and put caps. So all I did was I removed the syringes and added these caps. So the cell is ready. Open up the cell, or the NanoPlus. Like this, there's only one way to put this in. There's a little pin here that fits into this hole right here. So there's only one way to put this in NanoPlus. Close that. Okay. Now I'm going to switch to the software. So now we're doing Zeta potential. So I'm going to go here. I'm going to common create a new SOP for measurement. We can call this solid sample. Repetitions actually. Do this. We can call this measurement parameter 1. I added this 1 repetition, so I'm going to change this repetition to 1. So we only do 1 measurement. You can do as many as you want. I'm just doing 1 measurement for time's sake because I want to get to running your samples. So this is all set. I'm going to use Smokovsky because this is an aqueous solution. I remember Smokovsky is used for aqueous, is used for solvents or organic liquids that are non-polar. Yeah, I have the cell parameters already set. Flat surface cell. Okay, so I already have it on here. I'll set this to type 2 so it does the automatic cell centering. Zeta potential, flat surface. Good, so this one's ready. Add some measuring SOP, it appears here. And I'm using water. The water, we have the refractive index, dielectric constant, and viscosity already preset. Remember, we have, let's see if I can pull it up, a diluent list with preset liquids, and we have an entire library inside the manual that can be used. So you can try different liquids. For this one, the standard particles are suspended in water, so we're just going to stick with water for this cell. So we're ready. So I have another measurement or another cell in queue. I got to remove this one first. The message that I just received, it just tells me that I had a size cell set in here, and I'm switching to a Zeta cell, and the cells don't match, so I cannot run in sequence. So now that I removed that, now I say add to measuring SOP. And the NanoPlus will adjust itself till it gets the proper intensity. Double check something. Yeah. So I'll wait till this becomes optimal. It'll give me an indication down here. Okay. So start. We'll call this EMM8 water. Solid. And there we go. So now what it's going to do is it'll go through the cell center function. Remember that. Remember, I mentioned that when we do zeta potential measurements, we do multiple measurements at different positions in the cell. For the standard flow cell, we take 5 measurements, and the 5 measurements they look for the cell center. It labels that 0. Then it does 0.35 millimeters above, then 0.7 millimeters above, and it does the same thing below, 0.35 below, and 0.7 below. And what this does, taking 5 measurements, it can negate any kind of effect caused by electroosmosis, where when the particles are moving together in one direction, the amount of liquid they displace will be pushed against the sides and cause kind of like a backflow, like a current, or that's putting a force on the particles and an additional force on the particles, and that force can cause the particles to slow down, so you get an apparent mobility as opposed to a true mobility. So this kind of negates that electroosmotic effect, and you have more confidence that you're getting a true mobility. In the case of the solid sample cell, we actually take 7 measurements instead of 5. So it's going to do 7 measurements. It's going to look for the interaction of the probe particles with the cell, and it give you a zeta potential of the. It's going to give you a mobility of the particles, the monitoring particles, and it'll calculate a zeta potential of the cell based off of that mobility, or of the the solid sample. So this is finishing up the adjusting cell center. And you can see down in the bottom left corner, it'll tell you what it's doing. Base measurement is just the kind of like a background. So this is the background measurement right now, and it's going to be this is a frequency distribution, so it's looking at shifts in the frequency as the particles move. And that's how it calculates the mobility. And now starting test. Okay, that was a test measurement. So, I mean, it's all automated. It's kind of self-regulating. It checks itself. It does a test. It checks itself. Now it's actually going to measure the sample. The 3D graph, this area, this the right side, this is where it's going to display the different points that it measures. And the points should look like this, where it kind of goes one way or the other and comes straight down. If I have another better illustration of that. Yeah. It should, like, the only interaction the particles should have should be with the sample surface and not the cell. So it's taking this measurement at 0.8 millimeters above the cell center. Was there any questions so far?
No.
No. So I just finished the first measurement. Now it's doing the second one, 0.6 millimeters above the center. These values will appear once it's finished calculating and computing the surface zeta potential and then the zeta potential of the probe molecules or probe particles. For each point, it's going to do 10 accumulations. Accumulations is just exactly what it says, just a collection of data at that point. So it's going to do 10 collections and calculate a zeta potential at that point or that position in the cell, and then factor that into the overall zeta potential. So I just completed that point, did 10. So now it's doing the fourth point. Now this one is actually at 0, so this is actually at the cell center. If you want to kind of visualize this, imagine that the surface of the sample is up here, and then the surface of the cell, the quartz, that has a 0 charge is down here. Or just kind of visualize it. So that's 7 here. 8. Okay, so I finished the measurement. I can see here surface zeta potential negative 22.18. I could print preview this in a report format. And a report printout would look like this for this.
Can you tell us what's the difference of zeta potential value and surface zeta potential value?
I'm sorry, can you repeat the question?
So here there are two different zeta potential values, right? The first one is surface zeta potential, and the other one is only zeta potential. So what's the difference between them? The zeta potential value is actually zeta potential of the film.
Okay,
or
so are you talking about this area right here?
Yes.
Yeah, so you have the flat surface sample zeta potential. That's the zeta potential of the film.
Mhm.
Then the lower surface zeta potential, that should be close to zero, because that's the quartz.
That's the one?
No, but if you go to the results,
Yes. Oh, I mean, can you see the mobility result? Over the mobility result, there is also zeta potential value.
Yeah. Okay, so like I said, what this is giving up here, this part, zeta potential right here, where it says negative 9.71, that's the zeta potential of the monitoring particles. This is the mobility. This mobility right here, this is the mobility of the monitoring particles. And then for the actual film, the film is this value right here, where it's in bold. Flat surface of sample, negative 22.18. And then the lower one, that should be close to zero. That's the lower side of the cell, which is the quartz. And if you kind of can see the way it kind of shifts, it starts out kind of curving up here, then it kind of goes straight down here. The actual value that the sample, or this is the standard. Let me see where I put that package. The package somewhere here, and I forgot. Oh, there it is. Okay. The package, this value is supposed to be negative 17.9 plus or minus 10 millivolts. So this is in spec. And here's the specification. See if I could reach. Oh, sorry. I don't know if you can see that. It's not really clear on my webcam. Did I answer your question?
Yes, thank you.
Okay. So that's the report for the PMMA. Now